All right, new plan. We're actually ready to start because setup was that easy. And so I want to introduce and really thank the speakers from DoorDash, including Sudeep, who I've had a chance to know for just about a year now and heads AI and machine learning at DoorDash, as well as a number of folks and kind of members of his team. So they'll be speaking a little bit about personalization at scale and really looking forward to it. So thanks so much for joining us.
Yeah, thanks. Yes, thank you. And thanks, Dev and Predibase for inviting us. So let's do a little bit of a round of intro just to the speakers. So I, as Dev said, I head up the machine learning and AI in the new business verticals, and I'll tell you what that means in a second. Rohan, do you want to introduce yourself quickly? Yeah.
Hi, I'm Rohan. I'm a machine learning engineer at DoorDash. I work on catalog-related problems, so getting all the different items from different merchants and processing them and making them available for you all to buy.
Hi, I'm Simran. I'm going to talk to you a bit about personalization at DoorDash in a few minutes.
Awesome, thanks. So basically, we heard from Tinder. So now you have your match, you have the date. Now you have to order food. Who do you think about? DoorDash, right? So basically, let's do the show of hands again, like Tinder did. So how many of you have used DoorDash? Oh, everyone. Okay. So we win. We win. Okay, awesome. Great to hear. But how many of you have actually ordered something other than restaurant food from DoorDash? Much less. So this is where we have work to do, and that's sort of what New Verticals is about. So let me tell you about that. So our vision at DoorDash is basically to be able to deliver anything that's available in your neighborhood to your doorstep, right? And at high quality without defects. And this means that we have been expanding beyond restaurants. And, to capture all the shoppable moments that's around you, we need to go much beyond restaurants to what we call new verticals that includes grocery, convenience, alcohol, flowers, pet, retail, talk about it, electronics, like Best Buy is on DoorDash today. You can order anything. That's the idea. And when you think about that, right, so in the restaurant paradigm, you would order something, the restaurant will prepare the food, a dasher will go and pick up the food. That is no longer true in this new paradigm of new verticals, because now you actually have this person who needs to go and shop for you in the store, right? And then the other way the paradigm changes is that a restaurant menu probably has 100 items. But if you think about a Best Buy, they might have 100,000 items, right? So the cardinality of items and sort of like the way the consumer interacts with the product completely changes. So this leads to a sort of paradigm shift in how we think about ML applications at DoorDash as soon as we enter these new verticals, right? And to guide you through this a little bit, I have this graphic here where think of the three-sided marketplace that we're in, right? So there's the merchant, there's the consumer who is placing the order, and then there's the dasher who is picking up and doing the shopping for you. And in this three-sided marketplace, in the nodes and along the edges, there are many applications that require ML to be scaled. The scaled intelligence comes from ML and AI. So think about, you're browsing a grocery store on DoorDash, and we need to make sure that what you're seeing on those pages are personalized to you, makes sense to you, or anticipates the need, right? So essentially, if it's a grocery, if you're a vegetarian, you should not be seeing a meat aisle at the top, right? If it's something that you have habitually ordered alcohol on Fridays, we should anticipate that and show you an ingress into an alcohol shopping entry point on the store page. And then search, substitutions, complementarity that Simran will talk about, all these play a huge role in being able to build your cart. Now that you have built the cart, now we actually have a set of machine learning algorithms that then go and finds the best dasher that can do this job for you. So basically, a shopper that is working for DoorDash who is really great at picking beauty items at Sephora might not be the best person to pick up fish for you, right? So we need that level of personalization between the dasher and the task to be able to send the right dasher to do the right shopping. Also, there is supply and demand, how many dashers should be on the road at this point of time. There is models that are estimating pay. There are models that are basically saying, okay, this is an order that I can batch together with the other order. The same dasher can do 2 shopping runs in the same trip, right? And then there is basically navigating them both inside the store and on the streets. So talking about inside the store, right? So we need to know what's in the inventory right now, because if you place an order and if it's not in stock, then the consumer will not be happy. To do that, we're actually investing a lot in computer vision as well, which we will not talk about today. But essentially, that's also where VLMs and fine-tuning of VLMs come into the picture. So we're actually trying to use the pictures that dashers take inside the store to inform the real-time state of the inventory. And then, if you think of this triangle, the thing that is needed in every edge is information about every product we carry and the product knowledge graph, right? So how, is this bag of chips that I'm going to sell, is this, what's the flavor, what's the size, is it keto friendly, is it vegan? All these things we need to know to be able to sell it with confidence, right? And then also we need to know which store carries them, is it on the shelf right now? That's real-time inventory. And also we need the relationships between products, the ontology, so to speak. So essentially, if this bag of chips or this yogurt is running out of stock, we should be able to proactively suggest substitutions. And all this requires a solid product knowledge graph to be built. And Rohan will touch upon the product knowledge graph piece in a moment. But what I want to really touch upon is, because I was in ML AI for many, many years, and ML is not new, as we know, right? So essentially, in the sort of traditional world of ML, what we mostly used to be able to do is to learn from the interactions that happen within the system, right? So I was at Netflix for a long time, and we built a lot of algorithms, and mostly those algorithms learn from how people view things on Netflix, right? Similarly, at DoorDash, most of the traditional algorithms still learn from the engagement. But where engagement is sparse, right? So say Best Buy comes on DoorDash today, let's say, and we don't know anything about consumer engagement. Should we not do personalization at that stage, right? So these cold start type scenarios, it's getting much easier to solve them because now we can employ something, the generative AI piece, that has the world knowledge embedded in it. So even though no one has bought, this charger together with this laptop, the LLMs know. We can leverage that. So basically, the paradigm that we're seeing is the breaking into user behavior data with both on the user side, as Tinder also showed, and also on the item side, bringing in all that factual knowledge and also pouring in what the user has done so far and making sense of it is what LLMs are really getting good at, right? But devil is always in the details. In many of the applications that you'll hear, fine-tuning becomes essential to reduce hallucinations, to also meet the accuracy bar we need. Right? If you need to know this bag of chips is really allergen-free, we have to be very precise because otherwise someone's health is at stake. So how do we get these LLMs to the level of precision where we can be confident at putting them in production? This is the part of the story you will hear today, right? So without further ado, I'll just touch upon this slide, which is kind of the broader theme of this talk. So you cannot ignore traditional ML because that's the foundation, right? So if I want to do personalization, we still need two-tower embeddings, we still need deep learning models. But where the magic is happening is that where you're layering the generative AI on top of traditional ML, right? And I kept the second circle open because I don't know its infinite possibilities. So we don't know where it's going. But basically, the rest of the talk will touch upon different areas where we're using that sort of the overlay of generative AI on top of traditional ML. As I said, the foundation or the skeleton on top of which everything runs is the product knowledge graph. And so I'll hand it over to Rohan to talk about how we are leveraging GenAI to build our product knowledge graph. Over to you.
Thanks, Sudeep. Hi, everyone. I'll be talking about the product knowledge graph. And as Sudeep briefly touched upon, DoorDash gets data from different merchants, and then we build our internal representation called a SKU or stop keeping unit. I have an example here of Clorox disinfectant wipes. We have a bunch of attributes that we need to build a high quality SKU, and accurate and enriched information that something like what we're showing here is super important for both consumers, which are many of you, and dashers, which might be some of you, to buy the right items, supply them, and then have your order complete in the precise format. So one of the problems we tackle is attribute extraction. We take a lot of merchant data, which is noisy, sometimes incomplete, and convert it into this standardized format that can help power many downstream applications like personalization, which we'll talk about in a bit. So in doing that, initially our process was very human-driven and manual process. So there's a lot of noisy data from merchants. We have human vendors and in-house experts who manually process that data from different spreadsheets and different sources into a standardized format. This process was very slow, expensive, and error-prone to human errors. And so over time, we've slowly shifted from this very human-driven process to a more automated LLM-driven process. And it's been a journey. We started with simpler tasks and went on to more complex tasks, some of which I'll talk about, and also plan to share some of the learnings we've had along the way. So the first thing we tried was fine-tuning LLMs. Of course, there's the prompt tuning, as we saw in a previous talk, that doesn't work very well. And for our task, which was attribute extraction, which I briefly shared previously, attributes can be very domain-specific, and LLMs, of course, have little domain knowledge. So we needed to fine-tune LLMs on e-commerce data, on the large swath of data that we had, to both follow guidelines better and then eventually improve on the task performance. One learning we had along the way was that smaller models can also be performant. So on the graph on the right, started with GPT-4o with some prompts, got some performance, cost is high. Then we did some fine-tuning to actually improve the task performance to the point where it was useful for us. And then we did fine-tuning on a smaller model, so the 4o mini and eventually a Llama model, which then both brought down costs, increased speed, and still gave us good performance. So fine-tuning really works as like a starting point when you want to look to deploy models in production. And then moving beyond, so some problems require large context, and while there are big LLMs that can work with larger context, it's not always the best option. And so here I have a problem that I'm sharing, which is of categorization. So, different merchants, let's say Safeway, they give us some product, and now we need to categorize it. Is it within the drinks category? Is it personal care? Is it alcohol? Well, there's about 3,000 categories, and you can supply all of those to the LLM within the context window. There's like long context LLMs that's available, even with an API. But that typically leads to poorer metrics, more hallucination as you increase the context size, and of course, it's very, very slow, sometimes multiple seconds. So as Sudeep mentioned, layering traditional ML and other techniques with LLMs. Here we apply vector search. So create a vector index of the different categories that we have to a retrieval step. And then for the top few, we are able to send those to the LLM and achieve better metrics for the top K candidates by the model and get faster responses. Some of the tools we used were like FACE, as it's called, and the embeddings can be GPT embeddings or open source embeddings like ones for Flag. So once we had the RAG system working for some applications, we also found other applications where RAG didn't work that well, and we needed to go beyond the LLM's internal knowledge. So here I'm going to talk about agents. I have some input data from a merchant I won't name. So the input data is GR, PR, NTR, 4VV. It goes on, but yeah, it doesn't make a lot of sense. And even the LLM can't, there's a few more fields there, but even the LLM by itself can't make a lot of sense. So as we see on the right, there's the brand Gerber, which it got correctly. There's the size, which it also pulled out very well. But the product name, the Gerber fruit puree, apple and banana, that's not exactly correct. So human operators, when they used to build it previously, they had access to external tools to build these high-quality SKUs. So you could look up the merchant website, look up online, have other third-party data that we have access to. But LLMs are, of course, inherently limited by the knowledge encoded in their weights. So here's what we did. We started using LLM agents, and that automates reasoning-based tool calling. So if needed, if data is not enough, the LLM can perform a search either to an internal database or to an external website, to the manufacturer's website, for example, and create the right product name that we need. For example, here we see Gerber, Second Foods, apple, strawberry, banana. It missed the strawberry, it missed the exact name, and now it doesn't. So agents really help there. Of course, there's the risks of hallucination, and so strong evals are important when working with agents, and making sure that you tweak the prompts as well as the reasoning process so that it does not hallucinate as much, and you're able to validate the results once you get the results out. Finally, talking a little bit about scaling LLM inference. So, fine-tuning works well for task performance. We talked about drag on how to scale beyond context windows. But there are some other techniques that we apply. For example, model cascading. There's this funnel on the right bottom corner of the slide. So you start with heuristics, apply smaller models that can handle easier examples, and then finally you can also go to the bigger models. So here we show that we have millions and millions, order of 100 million SKUs that we need to process. Maybe we're doing a quality check. Maybe we're adding new categories, and so we add a big merchant, and there's lots of data. First, we process that with heuristics. Then we use some in-house fine-tuned models that cover a large fraction of the SKUs, and then only a small fraction goes to API models or frontier models. And what that has done for us is, one, we reduce the latency. Two, we reduce the cost. So if 88% of our SKUs are handled before hitting the large LLM, we're saving 88% of the cost, maybe 80% of the cost, because some of it, of course, is also on the compute. And finally, there's output distillation, so which is something I previously mentioned. There's take bigger models, tweak them, train them. You have that working in production, but of course there's high latency, there's high cost. Can you take that and condense or distill that into smaller models, whether that's a smaller closed source model or a smaller open source model? That has really helped us improve throughput, latency, and cost. And well, that's all about product knowledge graph and how you scale LLM there. And we've built a product knowledge graph both with human processes and eventually shifted to LLMs. But once you have this, what's the use if you can't use it to really support customers in downstream applications? So now I'll call upon Simran to share one of the downstream applications of this product knowledge graph that we've built. Thank you.
So you heard all about how the catalog is built, the product knowledge graph is built. But what about what we are doing for you? We are customizing it at DoorDash. You have your items ranked on every category page. We show you complementary item recommendations. Every collection you see is ranked, customized for you. And we are also curating special collections per customer. And how do we get to this? So there are two ways, right? We have the traditional ML. We have for existing customers, we have your purchase history, your preferences, brand affinity, dietary attributes, all your item interactions. So we can tell you what you like. That's easy. But what about new customers? What about when there are new products? As we keep expanding to new products, we are bringing in this cold start issue. So this is where the real world knowledge of LLMs comes in, and that is how we combine or blend these two to actually give all our customers a good experience. So one of the ways we do this is a hierarchical RAG-powered recommendations, and I'll give you an example of complementary recommendations here. And I know there's a lot going on here, so just look at the top right now. That graph there, that is a mapping of our catalog product. And like a really small mapping. This goes really levels deep, it goes horizontally really breadth, so you can just think of the product space we're talking about. And this is just product types. Think of the item space, which is much larger and is ever expanding. So if we actually want to recommend products, we need to bring in some sort of retrieval-augmented generation here, and this is how we do it. For example, we pick a leaf node or a terminal node, which is, let's say you want to get cake flour. And now I need to go and find what are the most relevant products that you could buy along with cake flour. Like I said, we have a large item space, so we need to filter it down to what's useful. You don't want a sewing kit with cake flour, so we go fetch that. A list of relevant retrieval items or product types. We get the LLMs to help us with the real-world knowledge, recommend what would be the most relevant items. We map it back to our catalog. Now, is this the most terminal or granular category? Probably not. So then we unfold it to the child nodes. And we keep doing this until we reach the terminal node for every product type. And that brings you to getting to butter, sugar, baking powder, frosting, vanilla extract. Now, all of this is just product types, and then we will expand and retrieve the relevant items for you. And all of this is just together to get what we are truly here for, which is cake. Now, once we have these recommendations, we want to evaluate these. So evaluation is going to, again, be by LLMs. So we're going to use either a more powerful LLM or a council of LLMs to evaluate these recommendations with a chain of thought reasoning. And we're not just evaluating the RAG recommendations, we are also evaluating from our traditional model. We blend these together, and we try to get relevant scores. Score 3, if things are highly relevant. Score 2, somewhat relevant. Score 1, not relevant. We try to get these filtered out, pass it through our metrics pipeline, so we have an aggregate of how we are actually performing, because we don't want to stop here, we want to keep getting better. And we also use the explanations as a feedback loop to improve recommendations, as well as identify our limitations, because RAG can't do everything today. So we spoke about how we are using RAG, but this not only helps us with cold start recommendations, it also helps us to bring in customers who are only on restaurant. We bring in some details for you into your retail behavior. We also use these as features and labels for ranking models. And like I said, we are also curating collections for you. I spoke a bit about how huge this catalog space is and just keeps expanding. That's one challenge. We have to keep making these trade-offs between granularity, space, and yeah, LLMs hallucinate a lot. So we need to maintain all of these to give you a good recommendation. You know what's the worst part? Even though it has real-world knowledge, it actually lacks larger catalog and item context just because you cannot increase the context so much. And then we need to map this back accurately to our catalog to retrieve the relevant items. So these are a bunch of challenges that we still continue working with. And that takes us to a next investment, which is semantic IDs. We want to create dense representations of an item which encapsulates the semantic meaning from the hierarchy of product categories, item context, instead of just a regular numerical embedding lookup. And we want to use these to then fine-tune LLMs so that your recommendations are now prompt-based. So this is going to actually simplify a lot of things. It's going to simplify RAG and catalog mapping, because now your output is a recommendation of IDs or semantic IDs. That means they have some meaning related to the prompt that we add in. It is suitable for cold start because it maintains a semantic meaning, and we can keep using free text to product retrieval. So items with home decor, they are going to have a semantic meaning against all the items and products that we have already mapped. And then this is suitable for other intent-aligned personalization, gifting, recipes, and just a ton more. So you can think of this as being very foundational, right? Because it is not just applicable to personalization. This is helpful for search. It is going to be helpful in all our agentic workflows that are coming up. So this is our upcoming investment area and what we are most excited about. But this is not the only thing. Sudeep's going to come in and tell you about the future.
So yeah, thanks both. So we talked about traditional ML to LLMs and layering them on our product knowledge graph and also on our personalization. We didn't get time to talk about search, but in search also this what is relevant, medium relevant, using strong LLMs as a way to generate labels is actually an emergent way of making your search more relevant. So we use stronger models to generate labels and then sort of fine tune cheaper models to actually get the precision high. But what's really, another area where LLMs are really good at is they understand context very well, right? So contextual and in-the-moment adaptation of the app, a lot of companies tried that, and some of them do it well. But with LLMs and agents, these things have become much more tangible. So for example, take this scenario, right? So it's like somewhere there's a tornado watch alert, and DoorDash wants to be your buddy and help you stock up stuff before the storm hits, right? And just this like context of there is a tornado alert in your area can be used in a sort of LLM plus agentic orchestration system to create a storefront for you, which is just like going to help you and guide you to this journey of like, stocking up for an emergency situation. But then, this is just one occasion, but you can also think of this as like, happier occasions, like, a birthday party you're throwing or a party you're throwing at home. But the same sort of like underlying technology applies. So in this case, right, so when we have this tornado coming, if you just go and ask ChatGPT, it'll come up with really interesting, and useful recommendations. So you need non-perishable food, you need water supply, emergency items. If we know that this person Emma has babies, it's the baby care items and things. So essentially, what you're seeing here is that if the agent or the LLM has memory, if the user's profile is stored, then it can work together with all the technology we talked about, both the product knowledge graph and the personalization technology we have, to create these moments in which the app is actively helping the consumer to build their cart and sort of like helping them prepare for a situation, right? Then it can go beyond like, just pushing things to the consumer, but it can also have a conversation, right? So it's like, in this case, Emma interacts with the AI. It's like, I also need quick meals that do not need refrigeration because the power may be out, right? So then the AI replies back saying, okay, these are like instant oatmeals and things that you can buy. And it can actually also have, agentic hookups into the real-time inventory system that we have. So it's like, okay, this store may not have all the things you need. We want to split the order between two stores, send two dashers out and get you the stuff, right? So if you think of this, the future is like, all that we talked about here, plus agentic. And this is kind of like the same similar sort of trend that Dev was showing in his slides, that at the end, what's new is the agentic bit, right? So just for this, for this situation, you can think of how, agentic assistance can help both on the consumer side and on the delivery side, right? So essentially, on Emma's side, we have long and short-term memory, what she's doing in the session, but also long-term memory. And then like this can react in the context of a tornado alert and help build pre-filled, carts and tailor recommendations. These agents can also reflect and say, what's happening with other consumers during this time of tornado, and learn from, what has worked, what hasn't worked. So self-reflection can help actually make this experience more precise, right? And then these types of, if you stand up MCP or ATA, whatever, right? So you can actually have these agents go and pick tools and chain agents as well to create this end-to-end experience for you. Like it hooks up with weather API, with the inventory systems, with delivery platforms, right? It can also do other delivery platforms for you, if you want to be really helpful. But on the dasher side also, you can think of like, it's a risky situation to go out in a storm, and the agent can help also the dasher to do a safe and kind of more intelligent way of fulfilling the order. So this is, I think, I just want to leave you with this in the sense like we started with very traditional ML and AI deep learning systems, two-tower models, learning to rank models. Then we layered LLMs. We had a huge product knowledge graph that was being built very, very slowly with humans. Now it's many, many times sped up with fine-tuned LLMs and agentic systems. But now you're also bringing in agents into the sort of end-to-end experience of the consumer. It's like in the moment, in the context, how we can make the shopping more magical for the consumer. So essentially, I will leave you with that. And thank you for the stage. And we can take some questions either on the floor or now. Thanks.
Thank you very much to the entire DoorDash team for joining. That was a fantastic talk, and it's actually really compelling to see how some of the things that I'm ordering are actually generated. We do have time for about 2 to 3 questions if you're open to taking a few. Does anybody have any questions for the DoorDash team? Maybe we can start here, and I'll try and circulate a microphone.
Maybe 2.
Thank you. You guys are answering. Hello. Hi, great. That was amazing. I really like the semantic ID parts, and I know you were doing it for items and item IDs. Are you also doing the similar thing for like user preferences and getting more niche user preference to fine tune on to be able to do like more in-depth tool calls with like MCP?
Yes, so we will always be bringing in personalization and, we'll always be bringing in personalization, but when we talk about semantic IDs first, we want to generalize the space so it is applicable across multiple use cases. It will go hand in hand with personalization because it doesn't work otherwise. You and I don't want to see the same products. Everyone here wants to see something curated for them.
Time for one or two more questions. I will see if anybody else has a question that they wanted to ask before.
There's one there.
Yeah. And if when you ask a question, if you might be able to introduce yourself, that would be great.
I'm Venom with SEMA.ai. I just had a question around fine-tuning versus RAG, if you can compare and contrast for your use cases.
Yeah, thanks for the question. So it depends a lot on the use case, is what we've seen. For situations where you need to provide a lot of input to the model, you would instead want to do maybe a two-phase approach where you have RAG, and you retrieve from a bigger set to a smaller set, and then provide that to the big model. And you focused on having high recall instead of high precision in your retrieval step. And then finally, you also want high precision in your LLM step or the generation step. So that's like the best use case for RAG. Now, fine-tuning can be done along with RAG. It doesn't need to be independent. So RAG can be a layer on top of your fine-tuned LLM to do the final ranking. So they're complementary in that sense. Thank you.
Yeah, Satish with AWS. Quick question on your agentic journey. Are you, that example that you showed, is that in production or is that something you're thinking
No,
of?
that's like what's coming next.